Finite math. In this video, we're going to solve a system of equations using a matrix. We're going to learn how to create an augmented matrix and then solve using the inverse matrix method, and we'll be using Symbolab.com today. As you go through the video, you're going to notice some icons on the left. This icon, we'll talk about the process. This icon tells us we're going to do some examples. This icon is for your practice. And then a self-quiz. And of course, what do you have to do to get good at it? Remember, it's not magic, it's math. So let's get started. Cases when matrix techniques do not work. There are two cases when inverse methods will not work. The first case is if the coefficient matrix is singular. That means it does not have an inverse. It won't work. The second is if the number of variables is not the same as the number of equations. Let me give you an example. I have two equations here, but three variables. My variables are x, y, and z. This will not work. Let's look how to change a system of equations into a matrix. We will have three parts. We'll have the coefficient matrix. For this one, you'll notice that our coefficients, 6 and 6 for the x, and then 3 and -1 for the y, times our variable matrix. Now our variable matrix, of course, is x and y, equals our constant matrix, 33 and 5. How do we make the augmented matrix? Well, what we do is we simply write the coefficient matrix, 6, 3, 6, -1, and attach 3, 5, the constant matrix. A lot of times you're going to see a line here. Now, if we solve this by hand, we would need to manipulate the equations until we have the identity matrix as the coefficient matrix, and our solutions would be the constant matrix. Now, what does that mean? That means when I manipulate it, I'll have a 1, 0, 0, 1, and then whatever numbers here will be my x answer and my y answer. But we're not going to do that. We're going to do a little algebra. But first, I want you to write the system of equations as a matrix equation of the form ax equals b. I want you to find the coefficient matrix and the constant matrix. I'll give you a moment. All right, let's see how you did. Well, here is the coefficient matrix. Now, how did I get that? Well, I have a 1, -2, 1, -3, 4, 1, 4, 0, because I don't have an x3 here, and then 2. My constant matrix is -4, 1, and -5. Now let's see how we're going to solve it using algebra. We're going to have the equation ax equals b, where a is your coefficient matrix, x is the variable matrix, and b is the constant matrix. So let's rewrite it. Using algebra, to get x by itself, I would have to divide everything by a. Using matrices, we're going to multiply by a inverse, or a to the -1, on both sides. That gives us a inverse times a times x equals a inverse times b. Well, hopefully you remembered from another video that a inverse times a is the identity matrix. Now, anything times the identity matrix is itself. To solve using the computer, we will take the inverse of the coefficient matrix times the constant matrix, and that's it. We're going to go to Symbolab here in a moment, but what do we have to do? We're going to take a inverse times b. We're going to enter the coefficient matrix A. We're going to make it an inverse by placing -1 as the exponent. Then enter the constant matrix and press go, and we'll get it. So let's see it in action. Remember, we want to put A inverse first. I'm going to take my A. I'm going to click here for my matrix. It's a 2 by 2. And type it in. Over arrow. Now, to get the inverse, we have to do the exponent -1, over arrow. I like to do times. You don't have to. We're going to multiply, but now we're going to multiply by the constant matrix, and that is this guy. Let's do this. We're going to have a 2 by 1, and that is 33, and 5. We're going to press go to see our answers. And look at that. We have 2 and 7. Now, what exactly does that mean? Well, we have x, 2 over 7. Now remember, x is our variable matrix. So this is telling us that x is 2 and y is 7. Now I'm going to check it really quick. I'm going to put 2 in for x and 7 in for y into the first equation. And look at that, it works. Let's do it for the second equation. I'm going to put 2 in for x, 7 in for y, and that one also works. Cool. Let's do this one together. Use the matrix inverse to solve the system of equations. First, what we want to do is find all the pieces. Here's my coefficient matrix. You're going to notice I have 0 because there's nothing there. Then we're going to do our variable matrix, and that is x, y, z. And finally, we're going to have our constant matrix, which is 1, 2, 3. We're going to take A inverse times B using Symbol Lab. First, we're going to enter the coefficient matrix. Then we're going to make an inverse by having the exponent as -1. Enter the constant matrix, and then press go. Let's go to Symbol Lab. All right, we're going to put in our matrix A, and that is a 3 by 3. So let's do that. Over arrow. Now we need it to the -1 because we want the inverse of our A matrix. I'm going to move this over just a little bit because our constant matrix is 1, 2, 3. All right. Now that we have A inverse and our constant matrix, let's go. And look at that. Our x is 0, our y is 2, and our z is -1/2. Yes, we can have fractions as solutions. And so x equals 0 to -1/2. That means x is 0, y is 2, and z is -1/2. You get to try this one by yourself. Pause the video, do it, then press play for us to check it together. Okay, let's see how you did. The coefficient matrix is 1, 2, 1, 2, -1, 2, 3, 1, 3. Our variable matrix is x, y, z, and our constant matrix is 1, 2, 4. For Symbol Lab, we're going to enter the coefficient matrix A. We're going to make it an inverse by placing -1 as the exponent. We're going to multiply by matrix B, and then press go. So let's go to Symbol Lab. Here we are. We're going to put in our matrix A first. Our matrix A is a 3 by 3. We need the exponent as -1 because we want the inverse of matrix A times. Now we're going to multiply by the constant, and that is 1, 2, 4. Now before I press go, you want to make sure that all of your numbers are correct, because one slight mistake and it's all going to be wrong. But let's go. Well, this is interesting. Is this what you get? Matrix is a singular? Yeah, you know what that means? A inverse doesn't have an inverse. We cannot use the inverse matrix method. Whenever the inverse of a matrix does not exist, we say that the matrix is singular. So either there are no solutions or infinite solutions, depending on the constants of the equations. So basically, we just say A inverse doesn't have an inverse. All right, you get to try this one, and yes, you will have an answer. And it tells us to round each answer to 2 decimal places. All right, let's see how you did. Hopefully you remembered to round to 2 decimal places. Our coefficient matrix is 34, 21, -25, 3, -13, 34, -14, -13, -9. Our variable matrix, x sub 1, x sub 2, x sub 3. And our constant matrix is 49, -29, and -6. Let's go to Symbol Lab. As you can see, I've already put in matrix A to the -1. That gives us the inverse matrix, times our constant matrix. Let's press go. Ooh, how crazy is that? Look at those fractions. I hope you write these down. If you haven't, pause the video, write them down, and then press play, because we need to change these to decimals. I'm going to show you how to do that right now. For x sub 1, you're going to take the numerator divided by the denominator and round it to 2 decimal places. X sub 2, the numerator divided by the denominator and round to 2 places. And x sub 3, the numerator divided by the denominator and round to 2 decimal places. X sub 1 is 0.67, x sub 2 is 0.29, and x sub 3 turns out to be negative 0.80. Cool! Here's another one for you to try. Write the given system of equations as a matrix equation and solve using inverses. For this one, you're going to notice that we have x sub 1, x sub 2, and x sub 3 as our variable matrices, as our variable matrix. But our constant is k sub 1, k sub 2, k sub 3. And what's that? K sub 1 is 8, k sub 2 is 8, and k sub 3 is negative 1. All right, pause the video, do it, and we'll work it together. The first thing I'm going to do is figure out my A matrix, and that is negative 2, 1, 0, 4, negative 1, 3, negative 1, 0, negative 1, times my variable matrix, which is x1, x2, x3, and that'll equal my constant, 8, 8, negative 1. Now let's go to Symbol Lab so I can show you what to do. You're going to see that I already put in my matrix A to the negative 1 because we want the inverse, times my constant. Now let's go. Look at that. We end up with negative 13, negative 18, and 14. But what exactly does that mean? That means that x sub 1 is negative 13, x sub 2 is negative 18, and x sub 3 is 14. Yay! Here's the self-quiz. You're going to pause the video, complete the questions, and press play to check. They give us our A matrix. A equals, now for A, K1 is 1, K2 is 6, and K3 is negative 1. For B, K1 is 3, K2 is 9, and K3 is negative 7. And for C, K1 is 7, K2 is negative 1, and K3 is negative 2. I want you to do these three. So pause the video, do them, and then press play so we can work them together. Okay, the first thing that I did was I created my matrix A. So 1, negative 1, 0, negative 16, 14, 1, 3, 0, negative 1, times x sub 1, x sub 2, x sub 3, and that's going to equal K1, K2, K3. What is that going to look like for A? Well, we're going to have the same A matrix times our variable matrix, but this one is going to equal 1, 6, negative 1. Let's go to Symbol Lab. We're going to put in a 3 by 3 over arrow. We want the inverse, so our exponent needs to be negative 1 times, and our constant. Our constant for this one is 1, 6, negative 1. And let's go. Looks like we get 19, 18, and 58. Let's see. 19, 18, and 58. All right. So for B, we still have the same, but now our K's are 3, 9, negative 7. To make our lives easier, our A inverse is still the same, so all I'm going to do is change my K. Press go. And it looks like we have 44, 41, and 139. Let's see if we're right. 44, 41, and 139. Awesome. Let's do the last one. For this one, we're going to have 7, negative 1, negative 2 for our K's. Just like the last one, to make our lives easier, all we're going to do is change our constant matrix. There we go. We're going to go. And we get 95, 88, 287. Let's check to see if we're right. 95, 88, and 287. How cool is that? Remember, you need to practice to get good at this, especially using Symbol Lab. Now let me also warn you, if you do it and you don't get the right answer, go back and check to make sure all of your numbers are correct. When I was doing this video, for one of the questions, I had to go back and double check. Did you like the video? Why not like it? Did you really like it? How about you subscribe? Did it help you? Why don't you share it with a friend? Remember, it's not magic, it's math.